Okay. José Carlos Baquero, he is director of the Artificial Intelligence Department at ETSE-UV Solution. It's a company that is in Madrid, and I think you are also international.
Yes, we are international. We are a lot of branches. Also, we have a branch here in Valencia.
Okay. And he is going to talk about if it's fair machine learning, if it's possible or not. I'm sure you are going to enjoy it a lot.
Thank you very much. Well, I think this presentation it will be less technical than the others, but I hope this will be interesting. Okay, probably you know is machine learning or artificial intelligence are more and more uses to making decisions. And however, sometimes this making decision made for machine learning sometimes is unfair, and that produces some kind of discrimination. For example, if you're going to ask for a loan, or you are interrogated by a machine learning algorithm, and you are able to pay or not pay, or you're going to fail to pay the loan. Okay, and now that is increasingly the impact on society, and they are more and more concerned about the transparency and the fairness of this kind of techniques, like machine learning. Okay, we are facing a new scenario. More and more we have artificial intelligence with us. All people here know is in our pocket, in our phone. We use a lot artificial intelligence and machine learning technology. That's true. It's not on the street. The general people don't know that use. For example, when are using Siri or Google are using artificial intelligence, but the machine learning is around us. Okay. Well, at the first of the time, this article is in 2015. We believe in machine learning. This is the silver bullet for all our project or our problem. In fact, this journalist wrote this article in the New York Times, and she said, this is a fragment for the article, the hiring could be faster and less expensive, and lead recruiter to more highly skilled people who are better matches for their companies. They said the software relies on data, and this software, based on data, is free of human bias. Journalists received a lot of critics about this article because that's not true. In fact, 2 weeks later, she wrote this article is when algorithms discriminate. And she write how this kind of algorithms could discriminate when you are working in this case, in human resources and recruitment. And she said the software is not free of human influence. In fact, algorithms are written and maintained by people, and machine learning algorithms adjust what they do based on the people behavior. As a result, algorithms can reinforce human prejudices. Okay, that's true. It's unfortunately or not, the machine learning algorithm is like a mirror. This is the mirror where the people is programming this software. And now the governors are concerned on these issues. In fact, in 2016, the White House published this article, in his blog. It speak about the big risks and big opportunities of the big data, but the problem with the civil right. One extract of this blog mentioned the caution against the re-encoding bias and discrimination into algorithmic system. We are very about, we are using a lot the machine to making decisions, but probably these machines are biased. It's biased probably for our data, not for the algorithm itself. Recently, the World Economic Forum was released this white paper, How Prevent Discriminatory Outcome in Machine Learning. I recommend his lecture. And they said in this white paper, this is one strategy, why algorithms decision-making aids have been used for decades. Machine learning is posing new challenges due to its complexity, opaqueness, ubiquity, and exclusiveness. And also, they add governance and international organizations like them have a role to play, but regulation, as probably you know, tends to not keep pace with the technological development. Okay? We are very concerned about what happened with our data and what decision is making with our data. Now, in fact, machine learning we use a lot for decision making, from the credit rating to online dating. Machine models are increasingly used automatically everyday decision making processes. And more concerns are being voiced about the loss of transparency, accountability, and fairness of the algorithms making the decision. Probably you know the technology like deep learning or neural networks. These machine learning techniques is very, they lack a lot of transparency. We don't know why they take this decision. And the people is aware of that. In fact, machine learning could be generate some discrimination. There are some articles about that, no? And we need to step up and look for ways to mitigate emergent discrimination on models. Here I show two articles. Is the big bad data may be trigger discrimination, how this data, our historical data, could be trigger discrimination. And also a study, the machine learning bias. This is a software that used in the judges in the US that used to predict the future criminals. You know, the people make a criminal and they predict if the criminal will be committed again. Thank you. And they show, we need to put, okay. Okay. Sorry.
Please.
Okay, and they made some studies about this software. This software is used in the judges in the US, and they prove how the black people are biased, are discriminate, respect with the white people. And this policy is made it in the judges. It's very serious. Also, we should make sure that our prediction do not harm people unfairly, with certain sensitive characteristics like gender, ethnicity, etc. We are totally agree. This is our ethical. Okay? Like a human, we have ethical rules, and we should to ensure this kind of characteristic of our algorithms. Well, luckily, the scientific community react for that problem. In fact, bringing fairness to predictive model is an activity investigating. Luckily, Farley is finally taking serious. In this graph, you can see how many, the number, approximately how many papers are published related with fairness in machine learning. And the last 2 years, in 2016 and 2017, they had a lot of papers to study how to tackle this problem in machine learning. There are several approaches, but the main of these papers are focused on this approach. One of them is to try to understand what happened with the algorithms interpretability and transparency, allowing interrogate the algorithms to know what is that behind the black box model, like a deep learning. Or another approach is training models more robust and fair in the prediction, making putting constraint and changing also the optimization objective. This is the main approach for tackle this problem. Well, I would like to show you a toy example, but it's very, I think it's very clear to know what happened with this kind of software. Okay, probably you know the UCI database where we can get a lot of data sets, but we're going to take only the adult UCI. We're going to make a basic classifier that can predict whether or not persons' income larger than $50,000 a year. Okay, we have this data set, and we're going to train a basic algorithm to do this to try to predict this objective, this target. Well, there are a set of features, X, contain the input attribute, like all the model we know in machine learning, that used for making the prediction, attributes like age, education, level, and occupation. For the other side, we have a binary class level that the model needs to predict. In that case, it's only income is more than $50,000 per year, or less. The income is less or equal 50,000 euros dollars per year. And finally, we have a set of sensitive attributes. In that case, we take only the race, black or white, or the sex, male or female, to try to discover if there are any discrimination in this sensitive attribute. Well, the data sets are not overlapping, so the sensitive attribute, race and sex, is not part of the feature that are used to training the model. Okay, because if we easy, if you put this attribute in the model to training the model say that's the data I need. Okay, but no, we split this data. We take the other data, the other attribute. Our data set contains the information just over 30,000 people in the US. Next, we split the data like always in train and set, but in this case, we split it 50-50, okay? And scale the feature using the standard scaling. We train the income level predictors, okay, and we would like to predict the probability that person income is larger than $50,000 per year. This is our problem. Okay, finally, we use the classifier to make income prediction with the text data, like always, and we get this metric. Okay, we determine the model performance by computing the area under the curve and also the accuracy, and we have this result is 0.9, the AUC, and accuracy is 85%. Well, it's nice. Well, you see these numbers for the first shot. It's nice. It's a very good predictor. However, this is fine. This is fair for white people, black and white people, or female and male. It's not. Okay. According to the algorithm, the person is black or female, there is much higher probability of the classifier predict an income below $50,000 per year, compared with someone white and male. And here, this is the prediction distribution. Here, for example, in race, black and white, you can see for the black people, the more probability is to become more than $50K is lower, okay? Then you can see the difference between the black people and the white people. And also, this is bigger difference between female and male. Everyone understand this graph? It's quite interesting. How the algorithm discriminate? Probably they don't know. I'm sure they don't know. But the data is discriminate the prediction of the race people or the sex people, or the sex attribute. But predictions are definitely not fair when consider the context and race or sex. And this is a very concern for all of us. Okay, we know that we have a problem, but you know is the mathematician or the engineers need to some metric to measure if one is, in this case, fairness or no. How to measure the fairness? Okay, there are several metrics for that, but I would like to use that, the P rule. The P rule is the ratio between the probability of positive outcome given the sensitive attribute being true and the same probability given the sensitive attribute being false. It's not than P over 100. It's like a twisted tangle, isn't it? That's true. If you have for the last example, okay, if we have the probability of the 50K, the income is more than 50K, when a condition is what is one person is white over the one person is black. This is the ratio, okay? Okay, we have a metric, okay? Let's apply for our model. And we compute, and this is the figures. For sex is 32, and for race is 45. It's a big difference. Because usually we have the threshold of 80%. And we are very, very behind these figures. Then we are not happy. In fact, we don't understand what happened here. The trainer classify is unfair in making prediction. And probably we use that for, well, or the bank use this kind of algorithms to give us a loan or credit. I'm sure they use that. Okay, and we don't know if these algorithms are fair or not. I think it's a very big concern. Okay, well, I would like to show you one approximation to tackle this problem. This fact is, well, this technique is adversarial training procedure, and is how to say, is based in generative adversarial networks. Someone here in the room know the GNA, the generative adversarial network? Another people? No? Okay. I'm going to explain a little bit, okay? GNN is an system of two neural networks. One is called generative model, and the other is adversarial classifier, which are competing with each other in a zero-sum game. For one side, the generative model is focused to produce samples that are identical to the real one, to the real data. But the other side, the adversarial classifier, try to identify if samples come from generative, artificial, or are real. They have to identify the samples came from generative model, is artificial data, or from the real data. And both networks are training simultaneously, such as the first improve producing realistic samples, while the second become better and better at spotting the fakes for the real. And this is more or less the the schema for that. No? I have this is not a network, a generator. They generate samples. For these cases, generate artificial images, but also we have real-world images, and we put for we get for the discriminator, and the discriminator have to discriminate, have to classify if real or fake image. Okay. This is the generative adversarial network. There are a lot of papers about that, and this is acute age technology, and we're going to use this approach to tackle the problem about discrimination in machine learning. In fact, we call adversarial training procedure. First, the generative model generates actual prediction. Why? This is the probability of a person income larger than 50K, based on the input of X, for the inputs of the data we have. Okay. And second, the adversarial classifier predict the sensitive attribute, that's it, sex or race, from the predicted Y for the classifier. Okay, they take the probability that predicted for the classifier, and with this data, they try to figure out what race or what sex is the people behind these figures. And this is the schema. Okay, it's this is the deep network for the classifier. They receive this data, input data, and they produce only one number. That is the probability of to have an income more than $50,000 per year. And the adversarial take these figures, this number, and trying to figure out what is the sex and the race of the people of the data. And finally, the objective of that bots are nets is try to optimize based on the prediction losses of the target and sensitive attribute. We would like to optimize these two both losses. Okay. Now I'm going to explain a little bit more deeper this. For one side, the adversarial network. I advanced you. I told you before. It tried to predict race and sex based on the income level prediction of the classifier. Okay, this is the formula. We try to minimize, according to the parameters of the adversarial network, our loss in the sensitive characteristic, in the sensitive attribute with this data. Okay, then I would like to figure out what is these parameters. Okay, for the adversarial side. The adversarial does not care about the prediction of the accuracy of the classifier. It's only concerned to minimize what is the prediction loss of the sensitive attribute. It's focused only on the sensitive attribute. In this case, it will be race or sex. For the other side, the classifier objective, they have two objectives. It's twofold. She tried to make the best possible income level prediction, but at the same time, assuring the sensitive attribute cannot be derived for them. Okay? Because they would like to cheat for the adversarial side. Okay? And we this sentence is captured by this objective function. Okay? This is, I would like to minimize according the classifier attribute, the losses for the prediction of the income, the Y, with my attribute, minus lambda. This is, it helps me to lose, to weight these losses, lambda by the losses of the sensitive attribute for the classifier and the adversarial. Okay? Look, that is someone try to minimize a minus function. Really, they want to maximize the function. And what happens if I would like to maximize a loss function? I try to cheat the other side. I want to not discriminate what happens. To make the words classifier for the sensitive attribute. That I need. I would like to cheat the other side. They can discover what is the race in that case and the axis for this attribute. Now we can use this lambda to steer classifier towards fair predictions while sacrificing prediction accuracy. Okay, because probably, well, I can advance now. We need different lambdas for different attributes, sensitive attributes. Well, if we will recap, the procedure follows the step. First, we pre-train the classifier with the full data set. Second, pre-train the adversarial or the prediction or the pre-trained classifier, because we know we would like to train the adversarial with the outcome of the probably of the outcome of the more than $50K dollars. And the third step is an iteration. We made T iteration depending of the problem. Simultaneously, we train the adversarial and the classifying network. First, we train the adversarial for a single epoch while keeping the classifier fixed. I fix this network, they don't change, and try the classify don't change, but I train the adversarial. But the other side, the next step is we train the classifier on a single sampled mini batch while keeping the adversarial fixed. Okay, I fix one side and train the other, and I made iteratively T iteration, depending on how many iterations need to converge this problem. Okay, well, let's see the result. No, is fair or not fair? Well, we heuristically tune fairness, because this is another hyperparameter, fairness versus accuracy, and the lambda values set for race is 130, and for checks only 30. Apparently, it's slightly harder to enforce fairness for racial attribute than sex, because I had to weight more the race, than the sex. And this is the result. This is the same graph, but with different iteration. And we can see how the P rules are increased and rising, and how the accuracy and the oak is go down, but slowly, very slowly. We're going to reach 160, and this is our result. We lost only, well, I have in the next, because this is a book. Okay. This is the, oh, sorry. I think I fixed that. I fixed in my computer, but not in the USB. Okay, but in the presentation, I made the PDF, and we can do that. With 116, we reach more than 80% of the P rules, and also we only lose 7% of the performance of our prediction. And now we have a classifier in this case, in an algorithm, more fair. I think it's a pretty decent result. This is my opinion. Okay, we balance this distribution. What do you think about that result? No, everyone at the same time, please. Okay, I think it's nice. At least it's promising. Okay, because I'm finished. I'm making the conclusions. Okay, the conclusion for fairness machine learning is, well, to bringing fairness to predictive model is not straightforward as just removing some sensitive attribute for the training data. We saw in the example, if you don't take this sensitive data, even though they produce discriminative predictive models, it requires clever techniques like adversarial training, we saw, to correct the often delay-based training data and force our model into making fair prediction. Okay, making fair prediction comes a cost. It will reduce the performance in your model. That's true. Well, in this case, only 7%. Probably we could tune a little bit. But this will be relatively small price, in my opinion, to pay, leaving behind the biased world of yesterday and predicting our way into fairness tomorrow. And that's my presentation.